Welcome to Mission Control, everyone. Our target orbit today, Cambridge AS and A-Level Mathematics, Syllabus 1.8, Integration and the Volume of Revolution. As your flight director, my goal is to guide you through the critical launch protocols required to navigate this highly technical airspace without losing a single mark. So, strap in. Here is our mission flight plan for today. We're going to lock in on the core theoretical architecture, run through the standardized launch sequence, figure out exactly how to secure those crucial method marks, review some critical examiner warning alerts, and wrap it all up with our final mission checklist. Let's get into it. Phase 1. Core Theoretical Architecture. Look at this mandate straight from the official Cambridge syllabus. It says, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. What does that actually mean for us? It means rote memorization just is not going to survive this launch. The examiners aren't looking for human calculators, They want systems engineers. They want to see that you truly grasp the underlying mathematical architecture of what's happening. Think about it like this. There's a massive difference between a low-altitude approach and a high-propulsion pathway. Isolated topic study, that's just blindly memorizing the formula, pi times the integral of y squared dx. But cross-topic connections, that's where the real power is. That means understanding exactly how that integral actually relates to coordinate geometry, curve sketching, and causal relationships. You literally have to see the whole board to truly understand how that volume is generated when a curve rotates around an axis. So, to build out this theoretical architecture, your math processing has to specifically target 3 distinct cognitive domains on the examiner's radar. First, knowledge and understanding. You've got to know the formula, sure, but then comes application. You have to apply it to the highly specific constraints of the axis in question. And finally, analysis. You need to critically analyze your limits of integration. If you don't hit all 3 of these radars, your score simply won't reach maximum altitude.
Moving on to Phase 2, the standardized launch sequence.
You have got to standardize your mathematical approach. And I mean relentlessly following this 5-step sequence every single time you tackle an exam question. Step 1, identify key elements. Ask yourself, are we rotating around the x-axis or the y-axis? Step 2, apply relevant principles. This is where you select your integral framework and get it set up. Step 3, execute your analysis with crystal clear working and notation. Step 4, verify your results. And finally, Step 5, present it all in the appropriate format. Seriously, do not skip a single step here, or you risk total atmospheric burnup on your paper.
Now, when you actually hit that presentation phase, you absolutely must adhere to some strict conventions. We're talking proper headings, correct terminology, appropriate formats, and clear, readable annotation. Look, I know it might seem tedious, but failing to format correctly literally results in dropped marks. You are communicating your mathematical logic to an examiner. If that transmission is garbled, the mission fails. It's as simple as that.
All right, Phase 3, securing the method marks.
Okay, let's talk about the most anxiety-inducing scenario for literally any math student. Picture this. You've just spent 10 minutes calculating a massive volume of revolution, you've integrated your bounds perfectly, but somewhere, somehow, in that final bit of arithmetic, you drop a negative sign. Your final decimal is completely off trajectory. So what does this all mean? Does the whole mission fail?
Well, the answer is a massive no. Why? Because method marks can absolutely save you. This is your fail-safe lifeline, guys. Cambridge examiners award crucial marks for your process and your analysis, meaning a perfectly structured analytical framework where you clearly identified the elements, applied the right principles, and showed clear step-by-step working. That scores highly, even with a minor calculation error at the very end. Remember this, the method is the mission. Let's look at Phase 4, examiner warning alerts. We need to pay very close attention to these top 3 examiner alerts. These are the main reasons students fail to reach maximum altitude. Number 1, students forget to include proper format, which means losing incredibly easy marks. Number 2, students completely forget to check their format and presentation before finishing the problem. And number 3, answers are not specific to the context given in the problem. Brilliant math completely falls apart if it lacks context or formatting. That is a failed mission simply due to pilot error on the final checklist, and we definitely want to avoid that.
And that brings us to the absolute biggest examiner alert across the board. Show your working. Failing to show your step-by-step working immediately disables that method mark lifeline we just talked about. If you just magically write down an answer at the bottom of the page and it happens to be incorrect, that is a guaranteed, complete mission termination, 0 marks.
You have to show the examiner your logic engine running. Charting your path to that A-star orbit means you've got to scale your working up these evaluative levels. You usually start at basic descriptive math, just stating the facts. But then you have to move up to the analytical level, actually showing the relationships and the specific limits of your integration. And finally, you push into the evaluative level. This means identifying limitations, checking your assumptions, comparing alternatives, and providing fully justified recommendations. That top tier? That is exactly where the elite marks live. And finally, Phase 5, our final mission checklist. I want you to lock this simple mnemonic memory hack into your brain right now. IAEVP. Identify, apply, execute, verify, present. Those are just the first letters of our standardized launch sequence. When you're sitting in that exam hall, completely under the pump with intense clock pressure, and a complex volume of revolution question drops right in front of you, just take a breath and write IAEVP at the top of your page. It'll instantly help you recall the exact operational steps you need to execute.
So, you now have the exact coordinates to secure every single mark on the board. Identify your axes, show your analytical working, and execute that integration. But ask yourself this before you take your next exam. Are you just memorizing the coordinates, or are you actually learning how to fly the ship? Optimize your educational flight deck right now by subscribing to Ace the Exams. Keep your logic tight, drop a comment below with which Cambridge subject you're planning to conquer next, and I'll see you in the next explainer.